Welcome to 4.6, which is all about graphing things.
You need one of them.
Need a calculator, just needs to be able to graph stuff. And it's going to be a little bit different than our graphing that we've done before now, because before now there were like rules and a parent graph situation where we could not use a calculator. And now we're going to have to use a calculator.
Got to use it. So you're just going to have to make sure that your calculator's in the correct mode.
Yep.
That everything's lined up so that you can.
We're going to be in radian mode.
Radian mode. If you want to work in degree mode, that's fine. We're not going to spend a lot of our school year in radian mode. So you need to get comfy with.
You mean in degree mode?
Yeah. You need to get comfy with not radian mode. Or with not degree mode.
Not degree mode, which is radian mode.
Which is radian mode.
And so we have our window here at -10 to 10, both directions. And you can do one of two things. You could make different colors and graph all these on the same graph. You make separate graphs if that's easier for you to see, but we just provided the one graph for you, and you'll have to figure out how to make that work for yourself.
We're going to use a color coding system.
Yeah, so
it's going to work out.
The table of values is what's going to be most helpful because we want to plot points. Sin x plus x squared, you end up with 0, 0, and then 1, 1.84, so that's 1, almost 2, and then 2 is almost at 5. And then the other direction, -1, is at 0.158. So just a little bit above.
Little teeny tiny above.
-2 is at about 3. And so it kind of looks like a parabola, similar to a parabola at least, but not symmetric about the y-axis actually.
And if we were really to investigate, there's tiny little wavies on that parabola because of the sign.
Interesting.
Yeah, we'd have to really examine
You'd
closely.
really have to look at it closely.
Really check it out.
Yeah, because you've got x squared, which is a parabola, but you're adding to that the different values of sine x.
Or subtracting, as it were.
Right.
Well, if the sign turned out to be negative.
Right. Okay. Yeah. Okay. And so let's move on to y equals x squared times sine x. This one.
This is actually a fun one. I kind of like this graph personally.
A lot changes between adding and multiplying. Some crazy stuff can happen. So type that in. And on the Inspire, I think you need to put this multiplication symbol there.
Now on this one, the table of contents may help, but may not because of what's going on. So 0, 0.
-1.
All of it sounds like you need to try.
And -2, we're at
then look at this. At -4, we're at 12.
So that's
no, -4, 12. Up.
Oh, we're at 12.
Yeah. Wowzers.
And if you're looking at your graph, what happens in between here is we've got this downward and then
down and then bounce up.
Yeah, it bounces up. So, and I don't know that it may keep going down some. And
a little bit, yeah. Then way up, way up, way up, way up, and then it keeps going up, and then it's going to fall back down again.
Yeah, who knows how far it goes.
Yeah, and then it just goes further each time.
Yeah.
Oh, you're going to draw on our face if you keep going that direction.
I didn't.
All right.
And then the other direction.
Oh, hello. So then go on the other way.
It looks like it's got some like symmetry here.
A little bit of symmetry. So where we were at -0.84, now we're going to be at +0.84. That's point going the other way now.
Everybody else gets to celebrate my birthday, but I don't get to enjoy it.
1.2, so we're coming back down.
I don't get it.
Forward. Way down. So here it is, and it just bounces back and forth. But what is it doing? It bounces because the sign, S-I-G-N, of the sign changes.
Right. Because, yeah. I mean, you've got these values you're plugging in for x squared, and then you're multiplying them by these values for sine x that are going between -1 and 1.
The whole time.
The whole time.
Yeah.
So we've got bigger and bigger numbers whose signs are all of a sudden alternating. So that's a pretty interesting one.
Yeah, I like that one. This one's not too bad.
Now, this one you can kind of think a little bit
about, think it through.
about
See
what's
if you can
going on. Is that we've got this sine function, but instead of having values between -1 and 1, we're squaring all of our values, which means they'll all have to be positive.
Okay.
Okay, so we are going to still, I believe, be going through 0, 0.
Yes.
And then at 1, we're at 0.7.
0.7, I think that's like square root of 2 over 2.
Yeah, I think so. At 2, we're a little bit higher, 0.8. And then at 3, we come back down. Oh. And then 4, we're like halfway. Like what should be happening is we should kind of have like a bouncy sine thing going on.
Up, down, and then that's where it goes under. Where it goes under, you bounce up now instead of go all the way down. So it's like a little rabbit hopping along the bunny trail.
Yeah, it is kind of like.
Yeah, it's a little up to 1, down to 0, up to 1, down to 0, and basically where you were originally negative with your sine curve, you're now positive.
Yeah, and last, sine of x squared. So now all those values we're putting in will be squared first, and then we're going to put them into sine. So let's see how that changes things.
Whoa. Whoa.
That's
good luck drawing this one.
Graph. So 0, 0 is still there, and then at 1 we're at 0.84. So that's this general area. 2 we're at -0.75, and then it just kind of goes crazy. So we've got like this U in the middle. It comes down here, and then it just does this.
And then it just gets even closer together. It's like some scribble.
Yeah, and we'll actually talk about what this is called later on in the section, but that is a pretty interesting graph. So like the whole point of this is just type it in your calculator, make sure that you're getting, we're going to have a calculator up
we
there
got a
to see.
Yeah, right now.
Yeah,
Can't
okay.
you see it right over
No, I
there?
can't.
No, it's over there, up there.
Well, wherever it is. So just make sure that if you plug it into your calculator, you can actually get what's going on. You can get a table of values so that you can graph it.
Yeah.
And that's really all there is to as far as example 1 goes.
We graph these by hand. We're not going to make you graph by hand on these kinds.
Right.
Yeah.
All right, example 2. Again, we're going to have to use our handy-dandy graphing calculator, and we are finding the domain, range, and period of each of the following functions. And like I said, we're going to have to graph these and actually take a look at what's going on in order to do that. So we also, though, can think a little bit about what's going on. You should have on your screen a calculator that's showing you what the absolute value of tangent x looks like. And if you think about it, your knowledge of tangent, and then you just take everything that's below the x-axis and you flip it up.
Yeah, that's it.
That's what's happening.
So you know, you got the John Travolta dance move, you know, from Saturday Night Fever.
Right. Yeah.
Well, now there's no negative.
So now it's a field goal kind of situation.
Field goal, yeah.
So our domain is actually still going to be the domain of tangent because we still have those pesky asymptotes.
They're still there.
They're still there.
They didn't go anyplace, and that's going to happen. Oh, here comes that 2 pi k business.
The domain is all real numbers, so fancy R, but x cannot equal those asymptotes. Well, I believe there's an asymptote at pi over 2 because we know tangent.
Right.
Tangent has an asymptote at pi over 2.
Right.
If there's no horizontal stretch or shrink.
And then every pi units after that,
right,
you've got
plus
one.
pi k, where k is an element of the integer.
I love the z.
Yeah, you do.
Jeez, that's one of my faves. All right, the range then. Now, if you think about this, the range on this guy is going to be a case where, well, we're talking about absolute value.
Right.
That's distance.
What's the range of an absolute value function?
It's always positive. I mean,
it is. It goes from 0 to positive infinity.
Yeah, you got it.
And it looks like it does equal 0.
I concur
Okay.
with that assessment of the situation.
Right, and we already kind of talked about the period of this is still going to be pi because that's how often it's repeating. If you look between negative pi over 2 and positive pi over 2, you have like a U-shaped graph, and then from pi over 2 to 3 pi over 2, that same thing is happening again. So the period of this is still pi.
Still going to be pi.
You're
now,
gonna
sometimes
have
it changes.
Yeah, sometimes there is something weird that, like I think we'll see on this next one, that will change the period from what the original trig function is.
So you just need to be aware of what could possibly happen.
Absolutely. Be aware.
Be
constant
aware.
Vigilance.
Wow, constant. I like it. So coming up is the sine. Now again, use some intuition here.
Right, normally we've got like a here's sine, but we're going to take all those negative values and we're going to make them
Did you just
positive.
Did you just hulu?
Yeah, so we've got like this, look at the graph that's on your screen because it looks better. We've got this really bouncy thing going on.
It's like a rabbit.
It is like a rabbit. So the domain.
I almost hit one this morning on my way into the parking lot.
That would have been sad.
He did that across the parking lot and I
Yeah.
didn't get him.
Okay, well, good for him.
So the domain then is going to be the same domain that we had with the sine,
Right.
which basically you can put any number in there.
Any number you want.
Yep. But now, absolute value again of range.
Okay, we know it has to be positive, so sine has a range from -1 to 1.
Right.
But all those negatives are going away, so we'll be between 0 and 1.
Right.
If you look at your graph,
and we
you
can
should be able to
include
see
both
that.
of those endpoints on that, or
Yeah.
both of those points.
Yeah, both of those points are included. And then this is where the period changes because the definition of period here is how long does it take before it repeats? Well, if
Before you're repeating the original shape again.
Right.
Yes.
So if you look where we have this shape and then it keeps repeating and it's the same there. And so how much is it from here to here? It should be pi. Okay,
That's what I would say.
It should be happening really twice as often because instead of having that lower part which changes the shape, it comes back and it's the upper part.
It's only the upper only.
So you just have to pay attention. What you're looking for is how far is it between where it starts repeating.
And if you set your calculator, if you zoom trig or go into your settings and you can change the interval on your x values to some sort of favorable trig function, like you can actually type in pi over 4 or pi over 2, then you can use the tick marks on your calculator to help you determine what the period would be.
And you can actually, I don't know if you knew this, you can actually type in to your x min and x max -2 pi and 2 pi, and then it'll put those in. And then your x scale, what does it normally pick? What, pi over 2?
Yeah, you can use pi over 2 or pi over 4.
Yeah, so, and if you zoom trig, it should set it up that
Right.
way. But if you wanted to put it in, you'd do
You
something
can do
like that.
Yep.
Okay.
I gotta grab something out of Marcus's car.
Example 3, and I wrote here example 5 from the book because in your homework it asks you, it mentions example 5 from the book. So it's our example 3, it's the book's example 5. So now you're up to speed with all of that. This is a fantastic situation. We've got y
The
equals...
lights back here, I agree.
No, I meant on the trig.
Oh.
Y equals 0.5x plus sine x.
You know, these graphs are just fun. Not gonna lie, I like these kind of graphs.
They're amazing.
They are
because
pretty interesting.
These we actually could kind of graph without our calculator.
Right.
It asks what parallel lines does the trig function oscillate between? Well, think about sine x having a range from -1 to +1. It turns out that the function is going to oscillate between these two
What
lines.
is going on?
0.5x minus 1 and y equals 0.5x plus 1 because our biggest value for sine is 1,
Right.
and then we've got this 0.5x thing that's being added to that, and our smallest value is -1. 0.5x is still being added to that. So what we could do, oh, that's terrible.
That was, redraw that line. Okay, oh yeah, perfect.
Let me, oh.
There we go.
Okay.
That's wow. Look at how straight those lines are. That is incredible.
Thank you. So a -1 with a slope of 1/2 will be, okay,
I feel like that's
and
pretty
then
good.
a +1 with a slope of 1/2. Those are parallel lines because they have the same slope.
Yeah, totally
And
parallel.
what's happening is that our graph, if I plug in 0, I get 0.
She gets 0, yeah.
Our graph is going to go and oscillate between. I think it's more fun with sound effects.
You know,